Here's an example of how to set up atom inventory. Okay, we have our reactants and we have our products set up in a little table here. Okay, I want you to pause the video and I want you to figure out the numbers of each reactant and each product. Now, you are allowed, when you see polyatomic ions on both sides of the equation, to keep them as one thing. So you don't need to separate them. Okay? It gets kind of confusing if you separate them. Okay? So again, if you see polyatomic ions on both sides of the equation that is equal, just view it as one thing. So when we set up atom inventory, we notice that there are 1 atom of iron on each side, 3 molecules of NO3 on the reactants, and only 1 on the products. We have 1 Li on the reactant and 1 Li on the product, and we have 1 OH anion on the reactants, and we have 3 on the other side. So this right here means it's not balanced. If it was balanced, all the numbers would be the same on both sides. So how do we balance this? What we do is we're going to add coefficients. Again, I want you to pause the video and see if you can figure out what coefficients need to be put in front so that the numbers of reactants and products remain the same. Taking a look here, if we add a coefficient of 3 on LiOH, lithium hydroxide, and lithium nitrate, we get our numbers to be balanced. Here's some more examples. Here's an example of hydrogen gas plus chlorine gas makes hydrochloric acid. Again, we're going to add coefficients so the atoms of each element are the same on both sides. And we get 2. So if we set this up where we have H's and we have Cl's, we have reactants, and we have products. Okay? We have 2 atoms of hydrogen because of that, and we have 2 atoms of chlorine because of that. Now let's double check on the other side. Well, 2 times this 1 equals 2 got to make sure that everything's kosher here. And chlorine, we have another 2. So since these numbers are the same on both sides of the equation, then we are considered balanced. Here's another example. This one you'll notice a polyatomic, but again it's not on this side of the equation. So you have to separate the elements. Okay? Here is your atom inventory, and what you should get is 1 atom of carbon, 4 atoms of hydrogen, and 3 atoms of oxygen. So you have 1 here and 2 there. You have 3 hydrogens and 1 here. Okay, to make 4. On this side, you have 1 atom of carbon. You have 3 atoms of oxygen, and you only have 2 atoms of hydrogen. Therefore, are we balanced? Well, since both of these are different numbers, then we cannot say that it's balanced. So now we're going to add some coefficients. So what you need to understand here is that you want all your numbers on the reactant side and the product side to be the same. And when we add some coefficients, you'll notice that now our numbers are consistent on both sides of the equation, therefore we're balanced. Okay? Now, here are some examples. I want you to set up atom inventory, figure out how to balance these equations, and then I'll give you the answer. So go ahead and pause. Okay, so this is what we're going to do. We're going to take atom inventory. So we have Fe, we have hydrogen, and we have chlorine. On this side, again, we have the same on this side. Okay? So here's my reactants. Here are my products. Okay? So irons, we have 1. On this side, we have 1. This side, we have 1 hydrogen. This side, we have 2. This side, we have 1. And this side, we have 3. So automatically, you can see that this is an unbalanced equation, okay, because both sides are not equal, okay? So the first thing you probably want to do is you might want to balance the hydrogens here and the chlorines, okay? So automatically, what you should do is you should just read from left to right, okay? If I have 2 hydrogen atoms, I can simply just put a 2 there and now adjust my atom inventory. Well, now my hydrogens are balanced, but I'm still having a problem with chlorine. So we are going to have to do something here, okay? And what we're going to have to do is we are going to find a common factor here. And the common factor between 2 and 3 is 6. So let's go ahead and make this a 2 and make this a 6. Okay, now we readjust. So we have 6 H's here. We still have 2 H's there. We now have 6 chlorines, and we have 6 chlorines. Okay, so we're still not done yet. All right, but we're on the right track. Well, since I have 2 Fe's on this side, why don't I just put a 2 there and now readjust? So now I have 2. The last step is basically now just balancing the hydrogens. And that's an easy fix. All we do is add a 3 right there. And now we have 6. So this column here matches this column there, and we are balanced. Taking a look on the next one, we have reactants, we have products, we have SN, we have O's, and we have H's. Okay, and we have SNs, we have O's, and we have H's. So SN, again, equals 1, There's a 1 there. We have O's. So this 4 times 1 equals 4. And we have 4 H's. Do the same on this side. We have 1 SN. We have 3 oxygens. And we have 2 hydrogens. So automatically we already have a problem. Okay? So how are we going to fix it is the question. Well, again, moving left to right. If we take a look here, we have 3 oxygens on this side and 4 on this side. What if we put a 2 right there? Okay, now let's recount our atom inventory. Well, we have still 1 SN. We now have 2 plus another 2, which is 4 oxygens. And now we have another 4 hydrogens. Now we're balanced. The last one is basically the same thing. Okay, you just move left to right and figure out where to put the coefficients if necessary. So we have 1 magnesium on this side. We have 1 C on this side. And we also have 3 O's on this side. We have 1 magnesium on this side. We have 1 C. And we have 3 O's. So we are balanced. This one, we didn't need any other work. So this is how you check your answers. Hopefully you were able to somewhat figure this out. It's going to take a while, okay? But you just need to practice this and get in the habit of just moving left to right and redoing your atom inventory after you add coefficients. That's the key. And sooner or later, you will figure it out. It just takes patience.